Lesson 6-9, we are covering solving log equations and inequalities. So that's really our two main objectives with this lesson. So let me give you some examples like the problems you'll be doing on your homework assignment for this lesson. On 8 through 18 even, the directions will just tell you to solve each equation. And let me just cover a couple of things with you. It's still true based on what we've already learned in working with logarithms and exponential equations. When you're given a log equation like this, we need to convert it into an exponential equation. Okay, so here is this letter A written in exponential form. The base is 8. The exponent for 8 will be 4/3, and we're going to let this equal the variable x. So in other words, when we find 8 to the 4/3 power, we will have our answer. We haven't talked a lot about fraction, or we call them rational exponents. We've dealt with cases like this a lot where we might raise a number like 9 to the 1/2 power, and hopefully we understand right now that that's the same thing as saying the square root of 9. And the reason for that is because if you take this exponent, the bottom number of the fraction always represents the root. And you probably remember that for square roots, we don't write the index. We don't put a little 2 in there. It's always understood for square roots that that's a 2 for square. The top number of the fraction stays with the base. So what you're doing here is you're just saying the square root of 9, which is 3. Well, for other rational exponents like this, I want you to be able to do these without a calculator because that's going to come in handy for future math classes. I want you to be able to take 8 to the 4/3 and write it in radical form like this. So let me show you how that works. Pretty simple, really. We're going to put our radical sign. And just like we did here with the 2, it became the root. Well, in this case, it's going to be the cube root. The bottom number always indicates we call that the index, or the root. And the top number just stays with the base. And so we're going to be doing the cube root of 8 to the 4th. And you might be thinking, wow, that's a pretty big number to have to figure out without a calculator. But not if you think of it in two different pieces. Okay, think of it like this. Just tell me or think about what the cube root of 8 is. The cube root of 8, hopefully that's pretty obvious to you. That's just 2. Well, all we do now is take this result 2 and raise it to the 4th power. And we get 16, which is our answer. Now, something to keep in mind, and we've talked about this a little bit, but I just want to remind you and then give you something else to think about. The number that you find here for x, it cannot be a negative number. We've already mentioned that it's impossible to evaluate log of anything negative. And that's also true about 0. That really hasn't come up very much yet, but just think about it. If I gave you log base 7 of 0 equals x, which means you're going to take 7 and raise it to some power and get 0. Well, that should be really raising a question mark in your head. How can I raise something to any power and make it 0 when the base of the log can't be 0? So bottom line here is when you find your solution for x, it has to satisfy this. It has to be a number greater than 0. Well, obviously 16 qualifies, so we're good. But just be careful when you get your answer that it satisfies this domain. It has to be a number bigger than 0 to qualify as a solution. Okay, letter B. In exponential form, it would be base 9 raised to the exponent 3/2 will give us our answer. In radical form, that's the same thing as the square root of 9 cubed. And just think of it in two pieces. The square root of 9 is 3, 3 cubed is 27. And my answer here, it definitely satisfies the domain of being greater than 0. So my answer for letter B is 27. Letter C, same thing. We'll take the base 16, we'll raise it to the 3/4 power, and that will give us our answer. So I want you to show me what this would be in radical form. This would be the 4th root of 16 raised to the 3rd power. And again, just think of it in 2 parts. Do this part first. The 4th root of 16 is 2. And then just take 2 and raise it to the 3rd, and you will get your answer. And then again, just make sure that your answer for x satisfies this statement of being greater than 0. All right, let's try this log equation. We had something like this on your test, so this might be a little bit of review for you. We still need to put the log expressions on the same side. So I'm going to subtract log base 2 3x from both sides to make it equal 0. Now I can put 2 logs together as 1 using the quotient property. Okay, now I'm ready to convert this. Now that it's in a single log form, I'm going to put it in exponential form. 2 raised to the 0 power is equal to x squared minus 4 over 3x. 2 to the first, or 2 to the 0 is just 1, so hopefully you can see how I got to my next line. Just multiply by 3x on both sides. I'm going to set it up as a quadratic equation in standard form. Subtract 3x from both sides. I'm going to choose to solve by factoring. You could use the quadratic formula if you prefer. And my 2 answers, at least I think they're answers, are 4 and -1. However, putting both of these to the test, I noticed that if I do let x be -1, I'm going to be doing the log of base 2 of -3. Cannot evaluate the log of a negative number. And so really 4 is the only valid answer of these 2. Okay, let's try one more. Once again, I'm going to get my log expressions on the same side of the equation. So I'm going to subtract log base 3 2x, make it equal 0. Put one log together using the quotient property. Change it now into exponential form. Multiply by 2x on both sides, realizing this is just 1. So 2x is equal to x squared minus 15. Set it in equal to 0, standard form. I'm going to once again factor it. You can do x minus 5, x plus 3. Factors of -15 that add up to -2. So we initially get the solutions 5 and -3, but once again, much like the previous problem, if we let x be -3, that's doing log base 3 of -6. That's undefined. So 5 is the only possible answer in this case. Okay, well, let's take a look at some inequalities, and this will be the second half of your assignment, 22 to 32 even. It's still true that we need to take these log inequalities and convert them into exponential. So this will be a base of 4 raised to the 3rd power, and we'll turn this around so that the inequality, it's pointing at 3, so it still needs to be pointing at 3. Say that's less than or equal to x. So this is pretty simple. 4 to the 3rd power, of course, is just 64. I prefer to make this x is greater than equal to 64. And it's also still true that the number that we get for x has to be greater than 0. Okay, that hasn't changed. Obviously, if we say that our numbers have to be, in this case, we're saying the solution is all the numbers greater than equal to 64. Well, that definitely qualifies. All of these numbers are bigger than 0. So we're good with this solution. I put a star by letter B because you need to be very careful in cases like this, in these less than cases. Let me show you. We'll go ahead and change this into exponential form. 2 raised to the 4th power is greater than x. Okay, see how I just turned it around. It's pointing at x, still pointing at x. 16 is greater than x, but I prefer to say x is less than 16. Okay, so let's think about this. We came up with a solution that says any number less than 16 will make this true. Well, there's a lot of numbers less than 16 that don't make this true, like 0, like -5, like anything negative. So I can't legitimately leave my answer as all numbers less than 16 because a lot of those actually can't work. They're undefined. So what I have to do here is create an inequality that will make it true. The truth is it's all the numbers less than 16, but at the same time those numbers have to be greater than 0. Okay, so if you think about it, what we're describing is all the numbers between 0 and 16. And the way we can write between statements, here's my such that statement. I can just do x between 0 and 16 like this. Or you could use our interval notation. In interval notation, it would just look like this. So I'm going to let you choose. You should be good at both of these. But for this assignment, you can use either one. All right, so that takes care of the letter B. Just be very careful. Don't just put an answer down when that describes a range of numbers, some of which cannot be used in this case. All right, let's try letter C. Once again, we're going to put our log expressions on the same side. Oh, should be minus. Log base 7, 6x minus 3, greater than or equal to 0. And we're getting a lot of mileage out of that quotient property, x plus 2 over 6x minus 3. Okay, we're ready to convert it into an exponential equation. And I realize that 7 to the 0 is just 1, so 6x minus 3 being multiplied on both sides I'll show that step to clear out this denominator. Here I'm just showing multiplying by 6x minus 3 on both sides. I'm trying to put x's on the same side, so I'm going to subtract x. I'm going to add 3. And I get my solution is all the numbers less than or equal to 1. Okay, but before we decide on that, let's take a look at each of these. Okay, before it was pretty simple. We just had to say x has to be greater than 0. Well, this is a little more involved because I have to let x plus 2 be greater than 0. And so to satisfy this log expression, I can only use numbers bigger than -2. Okay, now let's take a look at this one. To satisfy this log expression, I have to use numbers that are greater than 1/2. Well, here's the thing. When I pick numbers for x, they have to work for both of these. I can't pick numbers for x that satisfy one without satisfying the other. Okay, let's just take, for example, the numbers that are described here, numbers that are greater than -2, which that would include -1. Well, if I let x be -1, I'm okay here because -1 plus 2 is 1. That's okay, but I'm not okay here because -6 minus 3 is -9. I can't do the log of a negative number. So I can't use this set of numbers. I can, however, use these. Okay, greater than 1/2 would include +1. If x is 1, I get 3. If x is 1, I get 3. And that certainly works. And so what I'm going to do here is make another one of those between statements showing the numbers that are bigger than a half, but they also have to be less than or equal to 1. So that could look like this. It could also look like this in interval notation, and I want you to pay close attention to this because we haven't run into this a lot with interval notation. I still put the small number on the left, the bigger number on the right, but this or equal to in interval notation is handled like this. Okay, I put a bracket instead of parentheses. If it's just regular less than or greater than, I use parentheses. This or equal to, or in the old days, it would be the case where we have a solid circle over the number. Okay, that's what it used to look like when we graphed, but now to indicate that 1 in this case is part of the solution, we put a bracket instead of the parentheses. But for this assignment, I would take either. Just be aware of both. All right, so that's your answer for letter C. All right, more practice. Letter D. Let's put our logs on the same side. I just subtracted log base 5 of 8x plus 9. And once again, the quotient property, 12x plus 5 over 8x plus 9. Now that I'm in single log, I'm going to change it to exponential. All right. I forgot to switch the inequality. Sorry about that. Notice how the inequality is pointing at the fraction, and it's still pointing at the fraction. Okay, so again, this is 1, so you're seeing this process many times. I just multiplied by 8x plus 9 on both sides to try to get x on the same side of the inequality. So I'm going to subtract 8x. I'm going to subtract 5, and now divide by 4. 1 is greater than or equal to x, or the preferred is x is less than or equal to 1. Okay, well, let's see how that works with these two guys. So take each of these expressions and find out what x has to be in both cases to make them not undefined. Okay, 12x plus 5 has to represent something greater than 0. X is greater than negative 5/12. Okay, I'll keep that in mind. Now for this guy, 8x plus 9 has to represent something greater than 0. So x is greater than negative 9/8. All right, so on the one hand, using our interval notation, and I know that both of these are greater than, so on the one hand, I've got 1. I know that the upper side of this limit is the number 1. All the numbers less than 1. The big question is, what's the lower side? Is it going to be negative 5/12 going here, or is it going to be negative 9/8 going here? Well, I hope you can see that it's going to be negative 5/12. And you can do a little test if you need to. This is negative 1 1/8, and a number bigger than that, the closest one that would be easy to check would be negative 1. Okay, well, if you let x be negative 1, then you're going to have a problem right here, because 12 times negative 1 is negative 12 plus 5, that's negative 7. That can't work. Okay. It does work over here, but it doesn't work for this one. However, if we let negative 5/12 be the other end of this range, we are in good shape. So my final answer will be all of the numbers between negative 5/12 and positive 1, and we show here including positive 1 because it says less than or equal to. All right, I think I got one more, so this will wrap it up. So once again, put your log expressions on the same side. So that looks like this: log base 9, 9x plus 4 minus log base 9, 11x minus 12 less than or equal to 0. Quotient property again, should be really good with the quotient property after this. Get some good practice. All right, now exponential form, 9 to the 0 greater than or equal to 9x plus 4 over 11x minus 12. 11x minus 12 greater than or equal to 9x plus 4. 2x greater than or equal to 16. X is greater than or equal to 6. All right, so let's see. Not 6, 8. 16 divided by 2 is not 6. You're thinking, what in the world? Okay, so let's see. Let's take each of these and see what's required. We have to make sure that 9x plus 4 is greater than 0. 9x is greater than negative 4. So for this to be valid, we have to have numbers that are greater than negative 4/9. And here we have to have numbers that are greater than 12/11. Well, our overall solution, we came up with numbers that are bigger than 8. Well, that definitely satisfies, let's just take for example 9. Well, 9 is definitely bigger than negative 4/9 and it's bigger than 12/11. Any number 8 and above satisfies each of these. So we can just let this be our final answer. All the numbers greater than to 8. So just want to give you a word of caution. Don't just come down to a solution without considering what has to work for these expressions in the given problem. So if you just take a moment and take each of these expressions, let both of them equal or be greater than 0, solve for x, and then compare these results to your final answer, and you may have to make some adjustments. In this case, we did not, because our final answer included numbers in both of these. Our final answer satisfied each of these, so we were good. So just a word of caution. If you have any questions about these, this is your assignment. Hopefully this helps, and if you need any help, just let me know.